Polynomials overview. Before we go any farther, I want to make sure we understand some of the terminology within polynomials. What I have here are three major vocabulary components which make up polynomials. The first one is called our terms. Our terms are what is separated by the various, when I say plus or minus signs. This expression has three terms here. 45x, first one, 34y is the second one, minus 1 is the third one. This one has two terms, 12x cubed plus 36x. And this one has five terms, 12x to the cube minus 19x squared plus 16x plus 3y squared minus 14. Each one of these is a separate term. And there are five here. Now we'll talk about the coefficients. That is the number in front of the variable. I have 15x to the fourth. The coefficient is 15. 25y to the fifth, the coefficient is 25. And an 8, this is a constant. This is, the coefficient is 8, because technically, when we look at anything with a group of variables, this is the same as 8x to the 0. And anything to the 0 power, when we have that in a superscript, equals 1. Note that equals 1. So 8 times x to the 0 power is the same as 8 times 1, which ends up being 8. And that's going to be important later as we sort through these. And then the degree. This is the exponent. And 15x to the fourth, it's 4. 25y to the fifth, it's 5. And again, as I showed you a moment ago, 8, the degree is 0, because this is the same as 8x to the 0, and anything to the 0 is 1. So this is to the 0 power. Rules of polynomials. If a polynomial is anything with a degree that's negative, such as this one right here, this equation, 3x squared plus 5x minus 13 plus x to the negative 1. X to the negative 1 is a negative exponent. That's the same as 1 over x to the first, or simply 1 over x. And that is not allowed to become a polynomial. Same as this, 15y cubed plus 22y plus 12 minus y, 1 over y squared. And this is the same as I said up here, y to the negative 2. Again, not a polynomial. Also, we have to put our equations in standard form. This is not standard form. Standard form simply means the highest degree, whether it's x, y, or z, is first. Then the second highest degree is second. Then the third highest degree. And you see in this one, my highest degree is at the very last right here. And that's not correct. Second highest degree is right here. It needs to be in order from highest to lowest degree. Now, use some of our Latin knowledge here. What's a polynomial? A monomial means only a single term, whether it's a constant or a variable. 7x, 24y cubed, or 19. These are all monomials. There's only one there. Binomial, bi meaning 2, 3x squared plus 6x, that's 2 right there. 5y plus 12t, those are 2. 11j plus 8, there are 2 there. Trinomial, tri meaning 3. 4x squared plus 3x plus 1, there's 3 there. 2y to the 9th minus 15x cubed plus 4x squared, there's 3 there. And then 7z to the 24th minus 12x plus 22x y is 3. All kinds of variables floating around there, but there's actually only 3 terms. And a polynomial has technically 3 or more. We often call it polynomials when we see 3. That's technically a trinomial, but we often consider trinomials polynomials. But if it has 3 or more, it is a polynomial. This one has 5, 2x cubed minus 3y squared plus 4x minus 56. This one has 4. Erase that. This one has 5, and it has many. It has the word poly. 9x squared plus 2x plus 2y minus 15x minus 4. And this one has 6, 73x plus 22x plus 11z minus 19xyz plus 24, 42x squared minus 111. That is 6. Again, these are polynomials. Where do we use polynomials? One of the biggest examples is when we look at pest control. The boll weevil destroyed the cotton crop in the South. It actually invaded from Mexico in the 1890s. It's a beetle. Little beetle has a long snout. And this little snout right here, I'm pointing it right here, likes to suck on the boll of the cotton plant before it turns into that white cotton stuff. It's still green. This actually drove a lot of people, 410 farmers, into northern cities because if you look at this, these crops were being destroyed by the boll weevil. In 1972, they estimated 1/3 of all pesticides were trying to stop the boll weevil itself. There are a lot of socio-political considerations with the boll weevil affecting all our crops. Here in Georgia alone, in 1915, we produced 2.8 million bales of cotton. By 1925, it was down to 600,000 bales. And by 1983, it's 112,000 bales. Now, we rebounded by year 2000 with the eradication program. But you got to remember, the cotton industry here in Georgia alone provides 53,000 jobs directly, indirectly, with more than $3 billion a year. So there are practical considerations when we look at this in terms of socioeconomics and utilizing polynomials to determine this. So I'm going to show you. This is the actual equation for predicting boll weevil attacks and predation on cotton plants. The x-axis, number of acres available, and the y-axis, number of acres that are attacked. And what's interesting is, here's the equation, and we use this equation to predict where it's at in the cycle, whether it's here, or it's here. So let's remember when it peaks. This would be the worst case scenario here. And then usually it declines because there's not enough cotton anymore. And there's too many weevils, and there's not enough to eat, and they starve to death. But in the meantime, we've lost a lot of damage. Also, in looking at this equation, we also found out that females do 5 times as much damage as the male boll weevils do. So this determines, like, can we make certain types of insecticides that may not kill them, but actually make them sterile. Another area we look at with polynomial functions is looking at social media, the effects on healthcare communications. Whether we like it or not, social media has a great effect on what people do, what they read, where they get their sources of knowledge, whether they're true or not. And we look at healthcare, this is a very important aspect to understand where they get their information from. Looking at social media, where do people get most of their information from? If they trust someone, well, their doctor, number one, makes sense. Hospital, lesser degree. Health insurers only have about 42% trust, and drug companies have very little trust. So, how we disseminate health information, such as most recent COVID-19, it's going to depend. Is it coming from a doctor, a hospital, a health insurer, or a drug company? And we can see the uptake of this in getting messages out. For example, determining when people get their vaccine for COVID-19 or other health and epidemiological issues. A lot of it can be addressed because people use social media for all their information. And we did a recent analysis here to see what the uptake was over time of getting vaccines for the COVID-19. What I have here is actually the equation, which the polynomial function determined the uptake of getting vaccines. And you can see month one here, the vaccine came out through social media, how long it was, how people were responding to it. And it slowly goes up. It slowly goes up month by month. And then about month four, it really starts accelerating in a short period of time. A lot of this has to do with advertising functions in terms like once people have the message 4 or 5 times, they start utilizing things. They can see where the steady growth comes after that. But we can predict, even we have some cure, some miracle, some way to better something. But there's still a function that determines when it's going to start going. And this is the function right here for that. Now, another thing I want to cover is looking at input and outputs. The input is always the x, the output is the y, or the result. The x is the domain. This is what dominates our domain. It determines where the output's going to be. And the output is the range, and that's the y. So our x is always our input, our y is our output. No matter what, we can put in any number in the input. When we put it in the equation, in this case, y equals x squared plus 2, and I've actually put the solutions right here, it gives us the output. And remember, our input, which is our x, our output is our y. That is actually our coordinates also on the xy graph. If I input x, for 3 for x, my result is 11 here. Well, the coordinate is 311. Now, might be aware of some of these coordinates. Just so I want you to read them visually to know what you're looking at. Y equals x squared, it's an upward u. Y equals negative x squared is a downward u. X equals y squared is a u opening to the right, and x equals negative y squared is a u opening to the left. Similarly, third degrees. Now that was quadratics. This is third degrees, where you got an x cubed, the highest degree. And I've shown you how with my input and output right here, if you want to look at it in more detail with this coordinate. But basically, we get this kind of s function right here. And that's because when we have an odd exponent here, my negative is still negative. Negative 1 times negative 1, 1 squared, is 1. But negative 1 times negative 1 times negative 1 is negative 1 times negative 1 is 1 times negative 1 is negative 1. So the negative becomes negative. My input is negative, my output would be negative. Hence this shape here. Similarly with the quadratics, if this is y equals x cubed, again, I want you to visualize this for recognition. This is y equals negative x cubed. See, it's just a mirror of this one. And then x equals y cubed, and then it's a mirror of that one, x equals negative y cubed. Just recognize these. Notice on each, with the highest degree, gives you a parabola shape. This is y equals x squared. This is y equals x to the 4th. This blue one is y equals x to the 12th. The higher the degree, the more it plugs the function. Similarly, odd degrees, you still get that same S shape with x cubed, x to the 5th, x to the 7th. Now, one thing I want you to understand more than anything else is no matter how many monomials we have in this polynomial, the highest degree dictates the overall shape. I got, in the first one, y equals x cubed plus 2x squared plus 2x plus 1. But the highest shape dictates this overall S shape, highest degree. This one is highest degree is 6, and it's a little off center, but still basically a parabola shape. And then this one still has an S shape. The highest is odd, 3x to the 7th. So you still get that basic S shape.